Now I hand over to Firas Al-Janabi, who will moderate this lecture and present us the speaker of today. So Firas, the floor is yours.
Thank you very much, Hannah. Good morning, good afternoon, good evening, everybody. Welcome to our lecture. I'm sharing now the biography of Professor Nambi, so you can take the information if needed. But before that, I would like to introduce probably Professor Indumathi Nambi. So Professor Nambi is a professor at the Environment and Water Resources Division at the Department of Civil Engineering at IIT Madras, Chennai in India. She has received her doctorate in civil and environmental engineering from Clarkson University in New York, and has served also as a postdoctorate fellow at the University of Illinois at Urbana-Champaign in the USA. So Professor Nambi is an environmental experts member of the Ministry of Environment State Environment Appraisal Committee, Jan Javan Mission, and also Upanat Bharat Abhiyan. Hopefully I'm pronouncing this correctly. She is serving as an expert for the Committee of several departments in Tamil Nadu state government and also the central government of India. She has authored over 120 international journal papers, also several conference papers, technical articles, book chapters, and she has received 8 patents. She has also served as an editorial board for the editorial board and review committee of international journals. Dr. Indumathi is also the chairperson of IIT Madras Women's Forum and recently received highest recognition for engineers as a fellow of Indian National Academy of Engineers. When it comes to the core research area of Professor Nambi are the contaminants assessment in water systems, fate and transport, especially organic chemicals, microplastic, PFAS, and antimicrobial resistance and heavy metals. Other research areas include solid and hazard waste management, fluoride removal, wastewater reuse for agriculture, lake wetland restoration. And also she has been leading the Pan-Indian Carbon Zero Challenge contest. And this is an initiative to inspire and train and found youngsters to innovate technologies for environment protection. So far, it's an instrument in supporting 100 clean tech prototypes, and 30 startups have been successfully after coming out of this program. We are very happy from the DAAD perspective and also from the APCD Center perspective to receive the lectures today from Professor Nambi, and I will give the floor now to Professor Nambi to start her lecture. Thank you so much.
Hello, everybody. Thank you, first of all, to Hannah and Ajna for arranging this talk and for the nice introduction. So it looks like we have a very international audience. So I'll try to keep it a very international level of presentation. I think what I'm going to talk, the topic as you see, is quite applicable to any country because innovation and entrepreneurship has been in the forefront in the recent years in all the countries. And more so in the global south, I think we need to catch up a lot. So particularly in the areas of environment, water, energy, and other aspects of the global challenge. So I would address in my presentation some of the global challenges we have in water and why there is a need for innovation and how do we translate these innovations, what are the challenges when we try to translate innovations to startups, and what kind of supporting system we need to make successful startups in this domain, which is also very challenging compared to the other startups. So I will share my presentation. Yeah, so I hope we are on the first slide.
But not yet in presentation mode.
Yeah. Yeah. Okay. So I've restricted myself to water sector because like climate change and the environment sector is huge. And although we work in all these sectors, but this talk is going to be about the water sector. And a short introduction to the global water crisis. For a long time, we've studied about hydrologic cycle from school days, but for the first time in human history, we are pushing this global water cycle out of balance. These statistics we hear and see in recent times very often, so I'll just flash it here. Over half the world's population faces water scarcity. 8% of the GDP loss is expected by 2050 due to water crisis, and 50% of agricultural production loss is predicted, and we are still having a huge deficit in our water supply and sanitation systems for the human population. And water pollution is on the rise with more extent of pollution and new pollutants coming into the water domain. And also we know that with climate change, we have floods and drought on the increasing frequency and all associated disasters when these events occur. Right? And you may also have seen this new, I wouldn't say it's new, UNFCCC put up this concept because there was a lot of focus on climate change over the years with the IPCC and other bodies working with the countries to solve the climate crisis. But the other crises were kind of sidelined. So UNFCCC brought all the three on the same platform. One is, apart from climate change, we also have to look at the biodiversity loss, the pollution of the environment, land, water, and air are increasingly important and has to be brought to the forefront. Then came the planetary boundaries. This is a recent one. So 9 planetary boundaries were identified. As you see here, I have listed them. And what you see here across, this is like an unfinished like pie chart where all the 9 planetary boundaries are listed on the larger circle. And you also have a lot of smaller circles which define the boundaries. When do we think it is a crisis? What are the boundaries, and how many planetary features like concepts have we crossed these boundaries? Are we in the safe zone or in the intermediate zone or in a really serious zone where you cannot revert back, right? So these are the 9 planetary boundaries. For those who have not seen this, climate change is one of them. And we have 8 other things to worry about, which is change in the biosphere integrity, which includes biodiversity and functional integrity, land system change, freshwater change, the green and the blue water, and also nutrients, the biogeochemical flows, particularly the phosphorus cycle and the nitrogen cycle needs to be given the importance it deserves because life system depends on this. And ocean acidification is another huge problem. Again, all these are related and one might increase the impact on the other. We need to be open to that. Atmospheric aerosol loading, which causes a lot of other climate impacts. Stratospheric ozone depletion, we have heard about this for a very long time. And overloading with novel entities. That means new chemicals, new challenges putting on into that planet, which needs to be dealt with. Okay, so climate change is one of these 9. And look at that, we have already exceeded, if you count the sectors, we have already exceeded the safe green zone for 6 out of the 9 planetary boundaries. And water is almost there in the zone of increasing risk, but the biogeochemical flows, which is also related to water, we have already gone into the high risk zone. In climate change, we are also in the high risk zone for the radiative forcing and several others. The biodiversity, we have crossed the high risk boundary. We are nearing it for the land system change. So this is a very serious issue we are dealing with right now. So when we come to the contamination aspects, which I work a lot for my research, and many of our assessment studies are centered around chemical contamination in water primarily. Okay, so we have heard of microplastics on the rise, forever chemicals like PFAS, which you might hearing more often these days, chemicals from tires, which are just considered as microplastics, but there are more toxic chemicals in it. And then comes the increasing risk of our pharmaceutical products, particularly antibiotics and antimicrobial resistance. So many of these are completely unknown, at least the PFAS and AMR is, I find it is completely not talked about in many of the circles, like student circles, even faculty circles beyond the environment domain. But these are major threats which humanity is facing, including the microplastics, but particularly with respect to the damage it is causing to the human health, multiple organs getting impacted irrecoverably because of these impacts. So we have done a lot of studies around microplastics in and around Chennai, where I live, and also across India. We have looked at other studies done by people, and this is the more studies we do, we are seeing more reports of microplastics everywhere. You can see that the pristine Arctic and in the Antarctic waters, we are able to see microplastics where there is no plastic usage. So most of the time it has gone from the other zones to these pristine environments. And so it is coming back to us in terms of the salt, in terms of the food, fish. So because the entire world is connected. So, and it's impacting animals from small to large in all these environments. Some of the studies we have done in Chennai, I wanted to show some of the data because heavy metals are on the rise in groundwater, not only surface water. We are finding PFAS, the forever chemicals, which is now being talked about a lot in many, many systems where we studied, crossing the higher permissible limit of 30 nanograms per liter. And put together, definitely, they are crossing all boundaries in groundwater, river water, okay, and lakes, wherever we have studied. And as I told you, plastics are not only in the environment, now they are also found in human blood, in fish, in vegetables. Microplastics from even a small paper cup impacts humans. It's crossed the placental barrier, it has crossed the brain barrier, and so it has to be taken very seriously. Particularly in our studies, we found that we are the biggest polluters, and simple laundry load, every laundry load, since we are using materials like polyester in our fabric, they're releasing about 15,000 microfibers. Every cup of hot drink releases thousands of microplastics These are the actual studies done by IIT Madras and IIT Kharagpur. So we can do a lot as an individual, and we can do a lot as a student or a researcher working in this field. The other thing I wanted to talk about is the AMR, which is, again, as I told you, not much talked about. Policies are still not in place in the third world countries. India has yet to make a state level action plan on AMR for implementing and taking it forward. It's serious because AMR deaths are going to be the second largest cause of death next to heart attacks, exceeding cancer deaths. And again, in our studies, we have found persistent bacteria in indoor air, in apartments, in laboratories, in hostels. Of course, hospitals are a huge place where AMR can be propagated, but it also comes from animals. Improper use of antibiotics releases antibiotics and antimicrobial resistant bacteria from the guts of the animals and humans to the water bodies, from where these resistant bacteria contaminate humans. And if your body becomes resistant to any antibiotic which the doctors would prescribe you. It's a very serious case because we are not researching and creating new antibiotics. Very expensive to create new antibiotics to defend ourselves. So there is a huge demand supply issue in the antibiotic world. And of course, during COVID also, most of the deaths happened because of antibiotic resistance to the infection created post the viral infection. So global AMR data, alarming to see that many of the Asian countries, including India, has a high percentage of resistant bacteria found. African countries, Latin America, Mexico, where we see high incidence. So, and yes, more evidence to show the increasing drug-resistant infections. So coming back to the bigger picture, apart from contamination issues, we have to deal with these issues within the context of the Sustainable Development Goals. Right? So water is inherent in the SDG 6, and in many other, it's kind of intertwined in other Sustainable Development Goals like good health and well-being. Industry, innovation, and infrastructure has a lot to do with water, reduced inequalities in water supply, sustainable cities and communities, responsible consumption and production, life below water, life on land, climate action. All these are related to the water issues I just described. So specifically, water is focused on SDG 6. So SDG 6, Sustainable Development Goals 6, safe water and sanitation. Under this, there are multiple subsections. Where are we at this point of time in 2025, where SDG goals are set for 2030? It is quite alarming. We have not even halfway through the goals by even in 2025. Billion people lacked access to safe managed drinking water in 2020, and a small rise has happened since then. 2.4 billion people only had access to safely managed sanitation in 2020, and now it is reaching about 43% only. And also, the predictions are only 81% and 67% of the population will have access to safely managed water and sanitation by 2030. Okay, and current trends are not adequate. A fourfold increase is required to meet the targets by 2030. So these are the actual numbers from 2000 to 2020. There is a increase of about 10 to 12% in the water supply. The dark blue is what we are targeting. So 74%, about 5.8 billion people have safely managed water, and only 54% 4.2 billion people have about safely managed sanitation. So we are a long way. Apart from water supply and sanitation, integral water resources management is also inherent in SDG 6. And we find that in the current trajectory, we are not going to be able to meet the 100% mark. We need to double up. And 107 countries are not in track to meet this target. So, apart from these direct water supply and sanitation, we also have other issues. Water scarcity. 40% is affected of the global population are affected by water scarcity. So 1.7 billion people live in river basins where water use exceeds recharge. Extreme weather events such as floods and droughts are becoming more frequent and severe. Rising water temperature contributes to the proliferation of bacteria and viruses, leading to infectious diseases. And climate change is going to exacerbate everything, what I just said. So, having said all the challenges, what are we doing? What are the governments doing to address these challenges? And even though they are making progress, as we saw, it is not enough to meet the SDG goals. There is a need for interventions, more interventions in science, technology, and new ways of doing things. That's where innovation comes in. To meet all the demands what the water sector poses in terms of water abstraction, delivery, water use and demand management, wastewater management, water ecosystem management. Everywhere we need the influence of science, technology, and innovation primarily. First of all, we need to innovate to use analytical science. And second phase, we need to look at technology to address the problem. And in the third phase, we need to look at embedding this technology and scaling these solutions in the water value chain. And that is where startups play a very important role. And we have to do all this within the framework of economic and within the framework of society. So the planetary boundaries have a very short window of operating. If we focus too much on trying to solve the planetary boundary problem, the society, the economics will not work out. There may be huge costs involved in the water we are going to supply or the food we are going to supply or the energy when we are only focusing on environment. So we need to have some kind of a balance between meeting the society's needs, basic needs like water, food, energy, shelter, clothing, while we are addressing the environmental issue. So this is called a donut economics by Kate Raworth. It's a very recent concept trying to bring in environment, society, and the economical aspect. Technology solutions are going to have a big impact for solving this challenge. We need to look at holistic treatments, right? Holistic treatment technology. So most of the time in the past, technologies have been short-sighted. That's why we have not reached much success. So holistic treatment involves looking at the entire supply chain, both before and after. It's not just treating the effluent at the end of the industrial treatment, but looking at products, looking at raw materials while manufacturing. Can we look at alternative raw materials, which does not cause toxic byproducts? Right? It's not just important if you remove the pollutants from the water and supply it, but where is this pollutant going? It is ending up as a sludge. There is toxic byproducts in textile industry that it ends up in the salts. So what are we going to do with that? So it has to be a holistic treatment. Cost effective. The solution cannot be incur a very huge cost that the industry is going to reject it. It has to be cost effective. It has to have a low operating cost. Most of the time, we are worried at the capital cost and making it cheaper, But then it is either more energy intensive or there are frequent breakdowns and replacement costs, which increases the operative cost. So we need to design this system which is very robust with low operating cost and skill levels also. We need to make sure that it has to have like a low skill requirement, or if it is, needs high skill, there should be skilled manpower and capacity building incorporated into the costing. So low energy, carbon footprint. It also needs to have, we need to go step up our solution so that it not only treats the water, but also gives back the raw materials. Recovery of resources should be inbuilt. The circular economy models, what people are talking about in other systems, should also come into the water system. Successful business models should be thought about while a product is being built. So it is easy or pocket friendly for the industry and the government. And the price of the system is also not affordable for a common man. So it is a lot of challenging aspects. So there are a lot of challenging things to look at, not just solve the problem, but fit it within this boundaries and other challenges I'm posing here. So the old way of doing things may not work. Innovation is key. There are a lot of innovations which have come about, and focusing some of them in the water sector. Desalination has been happening across the world in coastal cities. But desalination, as I said, is often energy intensive and incurs a lot of materials like membranes, right? Very expensive membranes which have to be imported most often. And there is a problem with the reject. How do we manage the reject? So this startup has come up with a great idea. I'm going to show you some examples here, and then we can go back to discussing what needs to be done further. So it's a wave-powered sustainable desalination solution. It is right in the ocean, so the water is taken up and the reject is also sent back into the ocean. Satellite mapping technology-based startups are in the rise. Thousands of them have come about in the last few years, and it's a very powerful technology. Innovations are happening by the hour as we speak, including the satellite technology for solving water issues. Some of them I've listed here: mapping water bodies, monitoring water bodies, water quality assessments, flood and drought monitoring, land use and land cover change analysis for environmental impact assessment. The IoT integration, which are like putting in sensors, satellite imaging, coupled with drones with sensors, can go and actually sample water from hard to access locations. And the data from the drones and the sensors can be correlated with what the satellite images are telling us. So this can give us the big picture, and also we can zoom into the smaller scale and look at water body level mapping. So there's a lot we can do, and this area is booming in terms of innovation. Also, we have other new startups which are coming up using the power of AI, IoT, machine learning, data analytics. So these are some of the startups: SmartTerra, Shite, Fluid Analytics. They are able to detect leaking pipes very precisely and sending in the information in the matter of seconds so that the problem can be fixed. Water quality sensors are also deployed for continuous monitoring of water treatment plants, wastewater treatment plants, ocean monitoring, and sensitive areas mapping. AI has been doing a lot in terms of both water quality and water quantity. Other technology, these are like, I would say, deep technology for treatment of water, right, has been advancing in every field. Every industry is trying to innovate. Every water supply system is trying to innovate at a larger scale and also at a smaller scale. A nano bubble is a new concept which is coming up for delivering oxygen and ozone into the water environment. and making water treatment 100 times more efficient in terms of energy. There are also other technology like gray water treatment. This is an on-site. So from small scale to large scale, there are technologies. This is an on-site treatment which can be developed and installed in individual homes to treat the gray water within the homes and reuse it within their homes, instead of taking it in pipelines to a common treatment facility and bringing it back in huge network of pipelines. So the other AI enabled innovations which are coming up for large water systems planning and operation is the digital twins. So basically any new technology which is being developed in the labs, instead of testing it in a large scale system which involves cost and also a large risk, digital twins are developed on a system, computer system, where we can test these new technologies. So digital systems is actually a miniature version of a water treatment plant or a wastewater treatment plant or a lake system where we are going to intervene physically. So even before doing that, if you have it on a laptop and have all the functionalities mapped or modeled or simulated, we can actually predict what would happen when new systems are introduced. Either they can be new treatment systems or what happens when new pollutants are introduced in a treatment plant or in a lake system. So this is another emerging area for the startups. So we talked a lot about technology solutions. So, and I said that these technology solutions should be effective in solving the problem, but it also needs to address all these 6 A's, which has been put together. It has to be available, it has to be affordable, it should be there should be awareness for the people and of how this is important to their lives and health, so that they can use it. Accessible, sometimes, it has to be accessible to remote places in terms of usage and also cost. Ability, and as I told you, skill development is required if we need to translate this technology into the field. So with all the other discussions we have been presentation I have made, you must be aware, you must be sensitized on how challenging this problem is and how interlinked the other factors are. Apart from technology development in a lab, taking it to the larger field or the real field, deploying it in the real field is more challenging. Right? So how are we going to train? I hope many of you in the audience are students or in the academia. This is where I come from. So we need to train students to understand the big picture, understand the challenges, and also come up with solutions keeping these two in mind. So innovations are important. Like I said, technology innovations are important, but understanding the big picture is important. So in this program called Carbon Zero Challenge in IIT Madras, we call it as an eco-innovation and entrepreneurship program. So we train students to take their innovations from the lab, build on it, develop a prototype, and try to build a startup out of it. As we all know, there are like thousands of colleges in every country and about tens or thousands of million students graduating every year. And everybody comes up with, works on a project, 2 years for their master's, 4 years for their PhD, and probably 1 year to 6 months in their undergrad. Most of them just end there, and the students go on to build their own career completely in a different domain or in a different company, or move on to become faculty, and everything stops with a publication or at the most a patent. So it's just lying there and not utilized by where it is deserved to be sent, like an industry or a government water supply system. So how do we bridge these two gaps? The government or the industry are not ready to come and take the solutions directly from the academic. So there needs to be a bridge, and that bridges, I would say, are startups. Okay, so Carbon Zero Challenge is a program where we support student teams to build startups, to build prototypes, and to build a business model around their innovation. So far, we have successfully supported about 125 teams over the last 7 years across 5 cohorts. And innovations, we are open to innovations in any of these domains: air, energy, material, soil, and water, which are touching these planetary boundaries, sustainable development goals, triple planetary crisis in multiple ways. And here I would like to focus more on the water innovations. Every year we support 5 innovations in water. So far we have supported about 25 innovations in water. So what we do is select the teams from a cohort of 500, select 25 teams, fund them up to about 5 lakhs initially and 10 lakhs later to build a large prototype which can be deployed as a pilot in the industry or in the field. And network these teams with partners who would facilitate this deployment, linking them with NGOs, public agencies, to understand the real world problem and also to validate their solution. We put them on a platform to showcase it to potential market, which will be investors, government bodies, corporates, or even communities. And we also train them to develop impact metrics. What is the impact of their product in terms of how much carbon footprint it can reduce, how much water footprint it can reduce, so that these are special in the way of being a water startup or an eco startup. We need to know the impact they are creating. So some glimpses of Carbon Zero events. There is a web page you can look at for more information. So we bring a lot of government people and the industry people to see the innovations created by these startups every year. So this is the impact of the Carbon Zero. We are seeing about 125 prototypes, about 7 crore as funding has been raised and given to these startups. These are early stage startups, I would say, and students aspiring to found a startup. So we have trained more than 10,000 students. 25 startups have been formed as an outcome from these 125 teams. 45 others are progressing towards having a startup, and 13 ventures have become successful out of these 25 startups. Yeah, so among these, water and sanitation, 17 have been supported and 9 startups have been formed. So these are some of the water sector winners. So Germ Safe is an inline disinfection technology which can be put in bore wells. So the water comes out clean and safe. Solina is another interesting startup which has now got A-series funding. They develop robotic machines which can go into the sewer system in a manhole to detect clogs and clean them up instead of sending a manual scavenger. So it has a huge social impact also. Waste Chakra developed oil from plastics. Water Chakra is another startup I would show. They have a very circular sanitation approach. Water Chakra and Aryabhan have been working on circular sanitation solutions. Amvirat is another startup which has worked on removing water hyacinths from lakes which have been contaminated with nutrients. So yeah, I think I have separate slides for each one of them. Enviraj looks at monitoring industrial effluents, hand pump water, swimming pool water with very low cost sensors. JSP Enviro has developed a product for industrial wastewater treatment, particularly chromium, using microbial fuel cell and capacitive deionization. Yeah, this is the Water Chakra startup, which looks at complete circular solution. So the human based urine is segregated using waterless urinals, and fertilizers like ammonia and screw white are recovered from urine, whereas Aryabon complements Water Chakra, working on the fecal sludge, separating urine and the fecal sludge. The sludge is sent to a microwave pyrolyzer to make biochar using spent graphite, which is a very low energy technology. So completely, the human waste is treated in situ with very less energy, and it is an on-site treatment system which does not require biological treatment system, but very effective in terms of treatment and also in terms of returning byproducts like biochar, ammonia, screw white, and water for other purposes. Scrapified is one which removes microplastics and other pollutants, floating pollutants. AI-enabled drone is imparted into this boat, which can clean water bodies. Hydro toilet, the era of hydrogen now in the energy sector. Hydro toilet works on developing on-site hydrogen production using wastewater, again using human wastewater. Clean Water develops a wastewater treatment technology for removing the antibiotics and antimicrobial resistance. Phycosol develops microalgae-based products. And Electropulse Innovations uses very low electricity, ozone-based treatment technology. And this is a very interesting startup. Biodronex develops living carbon blocks from CND waste, which can be deployed under the sea for reconstructing coral reefs. So this is a block by block, we can build this, as you can see, a very low cost solution, and they have mimicked the coral reefs in a very exclusive design. And this is another startup which uses wave energy to power the ocean surveillance system. Amvirar, again, I told you about this. Neelhara is again using microbial fuel cells. Algae-based treatment systems can be used for wastewater treatment, and the algae can be recovered. Ionis is a new way of desalinating using capacitive deionization, which reduces less energy. So that's a whole list of startups which came from our initiative. We also thought that students have to be taught young in schools. They need to be sensitized about the global challenges and also about solutions. So Stockholm Junior Water Prize is a competition which is organized during the World Water Week, and where school kids, high school kids between 8th and 12th grade, are asked to develop solutions to solve the water challenges. So we at IIT Madras are the national organizers for India, and every year we've received about 360 plus applications from across the schools in India, and the top 25 are brought to IIT Madras to present their solutions. 5 national champions are selected, and 1 will be representing India in the Stockholm Water Week. That happens in August, the last week of August. So last year we had 1 champion from India. This year again we organized events, and very impressive to see how high school kids can come up with novel innovations with very little contribution in terms of money. Some of the glimpses from this innovation, and this is at Stockholm last August, when Manat, the national champion, took India's flag and walked proudly, talking about her innovation for grey water reuse within the house, was greeted by the crown princess. So it's a big inspiration for school kids to think about water challenges. Start when they are young. This will help them make the right decision when they are choosing college education and continuing their journey through their education and career in the water domain. So a lot of these are coming up now. Recently, I was in Switzerland. The Villars Institute organizes similar events to sensitize school kids on planet and the planetary boundaries and systems approach to solve these problems. So, yeah, I think having talked about the challenges and some ways in which the innovation ecosystem is trying to address these challenges, I would like to talk about the reality, right? So innovations, challenges are plenty. Innovations are on the rise. There are a lot of players, both nationally and internationally, who are supporting these startups. But still, these problems are there, glaring at us. Simple sanitation problems, water problems, water quality problems, water supply problems. Okay, so where are the gaps and how do we address these gaps? So the gaps, based on my experience over the years, are looking at again, the product is something which the innovators work on, but looking at it before and after the development of products is very important. So they need to look at for whom they are building these solutions, right? What is the customer's requirement? So there has to be a product market fit, as they say, right? So just innovating with brilliant ideas is not enough, but try to see who the customers are and build products to address the pain points of the customer. That is one learning we all had at the early stage. It can be a great product, but it can never go to the market. The other important thing is, even though the product is great, it addresses all the needs, there is still scaling up issues. And for that, we need a lot of support for the scaling up, the design and manufacturing. Innovators may not be fully equipped to do the large scale design and manufacturing. And also we need to take the support of other stakeholders like the government and the industry for the scaling up. So important to understand that innovation is not just technology alone. It needs to look at the bigger picture, right? There needs to be also policies in place, governance issues, which can halt the project. Often the technology people don't look at it from those dimensions, right? So it's not just technology, we have to look at the society, how it will be accepted by the society, and innovation, of course, is an integral part. It should not be just mimic what is there already, but an improved version of solution. Policy and governance is inherent for any startup to succeed. Pricing, policy is inherent with pricing, right? How do you price? How does the government, like India, the water price is very low for the community, right? The government subsidizes most of it. How can we afford innovation and technology, high technology, when the water is priced so low? That's a challenge. Similarly, sanitation sector. How do we put a high price product in the sanitation sector and assume that adoption will happen? Right? So there needs to be new business models also. Innovation should also be in the business model and not just in the technology. So, but the opportunities are huge. I don't want to just put a grim picture of challenges, but the opportunities are huge. World Economic Forum has predicted, has estimated the economic value of water, US 58 trillion US dollars. It's equivalent to 60% of the global GDP. So there is a lot of money. We need to tap the right problem and the right technology solution. Asian Development Bank Strategy 2030 estimates that the Asia and the Pacific require 53 billion per year in water investment. And so the banks are opened up to this, and they are ready to provide funding for these solutions scale up. In addition, in India, there is corporate social responsibility bill, which was launched. It mandates government corporates to allocate 2% of their profits to support social causes, and a lot has happened after this in the water sector, where multiple projects. This whole Carbon Zero Challenge is also supported completely by the corporate social responsibility funds of different companies, particularly Thales, who have supported this initiative for the last 4 years. Government like Department of Science and Technology, National Science Foundations across the world supports Water Technology Initiative, which funds academic R&D innovations in collaboration with the industry. So there is a lot of funding. Funding is not the problem. The problem is understanding the water challenge holistically. So when I say holistically, we need to look at other sectors and not just water alone, right? Apart from the social dimensions and economic dimensions, we need to look at other sectors like energy. Energy and water has a lot of nexus. So we need water for energy, like electric power, oil and gas. And also we need energy for water, right? Like desalination is a huge energy cluster. Wastewater treatment plants need a lot of energy to operate it. Okay, and there are a lot of things, but success stories, and there were also wrong policies when they were in place, without understanding this energy water nexus, right? Desalination may not be the right choice when you already have water surplus and adequate rainfall in cities like Chennai. Corn and jatropha are used for energy, which are like high water intensive crops, right? So a careful balance between these areas are important when policies are made and when innovations are happening. We cannot be one-sided. Adding more complexity to this, the innovators should also look at the food, water, and energy next. When the food is added, third dimension is added, we have to revisit and see whether the solution is appropriate, right? So, like I said, food crops food is required in terms of meat and also food crops. So again, growing meat has a huge impact on water, right? And agricultural land is taken away from the forest, right? So then there is another biodiversity angle to it. So all these are intertwined, right? So solutions which we provide should look at whether what impact solutions for water in particular should be decided based on careful impacts on how much energy it requires, how much land it requires. Is this going to impact the other essential demands for the society in terms of food and energy, right? So the big picture or the systems thinking is what people have now focused on. Adding another dimension, the dimension of waste. This is something which is not talked about in any circle, but it has evolved to become a huge problem and game-changing factor when decisions have to be made in terms of policy or technology in water, food, energy, right? Waste is often forgotten. For example, biogas plants are coming up everywhere, but there is no solution for the sludge, particularly in an urban setup. We don't have a place to make compost out of the sludge, right? Most often it is discharged into sewer systems, clogging the sewer systems. And many of the biogas plants have failed because although they produce biogas, they were not managing the waste properly. Other industries like textile, pharma, tannery, you can look at any industry, most of the focus is on the product, making better product, making new products. What is the impact on the water, energy, and most importantly, wastewater coming from these industries? How are they managed? What is the cost of treating this wastewater? right? So that is the forgotten dimension in many of the decision making, many of the industrial development in the past, and it has led to most of the problems we are facing right now. Because it's not just the environment which is impacted, but huge impacts on human health, ecosystem health, right? Right from the smallest of the living things are impacted by pollutants, right? Similarly, energy systems also play a role. Thermal power plants, fly ash is mismanaged. In oil sector, the sludge is mismanaged, right? So everything has an impact on the other. And so solutions cannot be one-sided. Solutions cannot be just solve a particular problem. We need to look at the other dimensions and other nexus. So that is why systems approach is very, very important when you're innovating, right? The other new thing which I wanted, which are emerging things which are often forgotten. I'm talking about the forgotten dimensions here. AI is the thing now, right? It's going to be there for the next few decades, dominating all sectors. AI means a lot, huge data centers, servers, right? And each of them are coming with a cost. High water and energy footprint.
Sorry,
Professor
Nambi, just in the sake of time, if we can close in 2 minutes to give also some space for the questions. Thank you.
Right. Thank you. I'm almost there. So this is another forgotten thing which people are bringing into the forefront. A huge amount of energy, as you can see in these numbers, for our energy guzzlers. For cooling purposes, we need water. The huge water and energy demand for these AI and data centers. Okay, and novel innovations. Any innovation in this sector is going to be having a huge impact and a huge market also, because this market has a lot of money, right? So every Google, DeepSeek, everybody is looking at lots of innovations. And the recent one in China, they have a data center right inside the water to take care of the cooling and other requirements. Semiconductor industry, which is again booming and spreading to some of the other Asian countries, has a huge water footprint because they need a lot of water. They need a lot of high purity water and solvent for manufacturer or manufacturing the semiconductor chips, which is going to have a big impact on the water environment throughout the world. So, yeah, a lot of countries are working towards it, how to solve this with the limited amount of water. How do we balance all these demands coming up? Okay, so challenges are there, like I told you, solutions are there. And so we need, as the challenges comes up, we need to innovate and create new business models so that you can be a prosperous startup even in the water sector. Okay, you have to be smart enough to choose the solution, choose the problem, build a solution, create a market, and become a successful startup. Right? There may be challenges in having a startup, but it is easy if you know how to navigate your way through the startup journey. And it is also easy. The governments should facilitate. As an innovator, you should start with customer discovery, go to product development, and good business models which can provide profit, and then come up with good impact metrics of your product so that it is marketable easily as a sustainability startup. Okay, and also come up with circular solutions so you can make profit out of your water startup. Government and corporates have a huge role to play. Government should facilitate startup with a special vehicle. Most of the water industry is managed by government in the Asian and African countries. So government has a huge role to play to facilitate, give a special vehicle for tender processes for startups. Academic institutes also have a huge role to play to inculcate the systems thinking and encourage students to develop startups when they graduate. Corporates can give the funding and also provide the challenges they are facing, and also provide a space for piloting these technologies. So everybody has a role to play apart from the innovator. And for successful startups to come from the water sector, we need to have all these stakeholders working together for a holistic solution. That's it from my side. Thank you all for your patient listening. This is my contact information. This is information about Carbon Zero Challenge. My contact information was shared earlier. And now I'm open to questions.
Thank you so much, very much, Professor Nambi, for this insightful talk. And also the interesting topic and these different levels that you have covered, focusing on very specific issues and going more to ideas of supporting the startups, and also reflecting some examples from the startup at IIT Madras. Before I go to the questions, I have a general question to start with. So this is more a general, not only about the water sector, all other sectors. From your perspective, what's the most effective strategy for supporting the young, so to say, business persons in building a successful startup? Maybe a short answer, because we have a list of questions. And
what is the, can you repeat it?
What's the most effective way in, from your perspective, to or effective strategy for supporting young persons in building a successful startup?
Yes. Yeah. So I think motivation is very, very important. I've seen people build startups as part of a class project, but then drop the idea. I think apart from all the support systems I talked about, the institute should have an incubator which can help them continue the journey. The basic thing is the fire in the belly, the motivation of the innovators to make their product successful. I think that's fundamental.
Thank you so much, but can you please stop sharing your screen, and then I will start with the questions from the...
I thought I did already. 1 minute.
So a question from Hussam Al-Bakri. What's the maximum accepted limits of the microplastic around the humans to avoid contamination and health issues?
Microplastics.
Yeah, what's
so the limit?
Maximum accepted limit.
Yeah, I think the science is still developing in that aspect. We do not have like toxicology studies needs to be done. And plastics are so different. Multiple plastics are out there, and multiple organs are impacted by the plastics. So there is no specific limit set. It depends on which organ it is going to. If you're ingesting, most of the time they say that there's no issue. Okay, but when you're inhaling it, it goes into your lungs. There is a higher risk. So the whole research is still evolving to set these limits for these new pollutants.
Thank you. Question from Fabian Fata, also thanking you for the talk and the lecture. And he was mentioning that the German government funded the Indo-German Center for Sustainability, where you were very active in that until the end of 2024. And the question is now, are startup research institution and society ready to face the challenges on their own? Or is there, from your perspective, more governmental and north-south support needed?
Yes. Water startups or anything to do with environment, I think there needs to be a support um, from the government. A lot of support from the government is required until they take off. A lot of investors needs to support. They need to believe. They cannot look for a short-term return of investment like they do for the other startups in the other field. Water or environment startups have a very slow growth, and so the return of investments would take longer. So we need a lot of support from the investors, the government, and industry to adopt it.
Okay, thank you so much. Now a question from Arina Frel. And this, how can new water technologies you mentioned be scaled to address climate resilience in vulnerable areas? And what are the major barriers to their widespread adoption? So if you can comment on that.
Yeah. Yes, like I said, they're all intertwined. Climate change is something which is also related to water, and it also causes a lot of water problems. So I would again say that understanding, how each, that particularly the energy water nexus can be one area where it directly impacts climate change. So we need to go for solutions which are having a low carbon footprint. Automatically the energy demands would be decreasing and the lower would be the climate impact. So, and it will be easily adopted also in countries where there is low energy reserves. Okay. So climate change is directly related.
Okay, thank you so much. And also, I think he's or she's commenting. It came to my mind that integrating climate modeling with water resources management strategies can improve enhance the precision of prediction made by startup solutions, and enable to be more focused on sustainable intervention in regions facing water scarcity due to climate change. And bringing.
Yeah. It is important to integrate both.
Sure. Bringing question now from Eric Onteo, and he's wondering why we have water shortages globally, yet we are surrounded by the large oceans. Do you think it's possible for desalination to work, especially in the African continent?
Like I said, desalination is a solution when you don't have a water surplus, because desalination is a high energy operation, high materials operation, a lot of membranes, and also high wastage of water. Almost 50% of the water goes out as reject after all the energy and material usage. So yeah, in African countries, the rainfall, depending on your rainfall and your demand, it's better to do a water management practice, better water management practice, so you can utilize the rainfall, store it, treat it. Reuse of wastewater can be an easier option, because let's say wastewater has only about 1,500 maximum salinity milligrams per liter of salt, whereas you need to desalinate from 30,000 milligram per liter of seawater to make it drinkable. So wastewater, desalination of wastewater is low energy intensive compared to desalination of ocean water. Right? So look at other options, and if you run out of all the options, then desalination would be the last option.
Thank you so much. And there is also another question from Fabian Falter. And Fabian is asking, as you have shown, so in India, water is, as you have shown, often not clean in scientific terms, but perceived to be pure in the spiritual dimension. Is this perception supporting or hindering in addressing the challenges of water security?
Yeah, I think there are serious, it used to be pristine and pure, or even now in the upper reaches of the Ganga, which is supposed to be a very holy river, they are still protected. But with urbanization, all the water bodies are now not fit for drinking. Maybe for bathing, taking a dip, it may be appropriate in some places. So yeah, we need to revive. There are different standards set for bathing, skin exposure. We need, all water bodies need to meet those kind of standards, at least to continue the religious practices, which is done like in India.
Thank you so much, Professor Nambi. I think the time we have allocated for this lecture is already done. I would like to thank you again for your insightful talk and different perspective that you covered within your lecture. I would like also the participants that have joined from different places around the globe for this lecture, and also would like to thank the DAAD Global Centres for making this climate lecture series happening, and also special thanks from our center, the ABCD Center, Global Water and Climate Adaptation Center, for all of you. And soon, I think this lecture will be on YouTube online. So I think you can get this information later. And then we will ask also Professor Nambi if she can support the providing the PowerPoint presentation, because some of the participants asked for it. And for that, I would like to close the session of today and wish you all a very nice afternoon, morning, evening, and see you soon.